Module 3 is a case study on a Toyota Sienna no start. So this is a crank but won't start, or won't crank. You be the judge of it, all right? Now, if you've worked on Toyotas, you've worked on Fords and other vehicles with similar architecture of hybrid vehicles. You've got a gas engine, you've got electrification system, electric motor generators and all that. You know this already. I want to review this. We're going to do a part B that's actually going to emphasize something that's even more important in today's electrified vehicles than used to be. But the point we're going to make here is we have a no start. And as an instructor, I did the no start. I bugged it. As other educators out there watching, you probably have done this same thing. This is a 2.5 liter inline 4-cylinder D4S, 2 sets of injectors, GDI, SFI. That's kind of irrelevant. It's got electrified transmission with 2 motor generators, MG1, MG2, just like you're familiar with. And this is a no start. Now watch this, watch what happens. Listen and look carefully at the video to see how I bugged it. I didn't try to cover the bugs up. I left them out there in the open for you to see. So the vehicle was off, it was readied up, it says ready. Sounds like it's idling. You see the coils are unplugged. All 4 coil unplug connectors are unplugged. How can it run without coils? It's not a diesel, it doesn't have that high a compression. It's running, or is it running? It's not running. The engine is not idling, it's not running, it's being cranked. How did I induce that? That's easy. If you've worked on these, you know that as long as there's nothing wrong with a hybrid, most hybrids, not plug-in hybrids, they vary. And of course, with the BEV, you don't have an engine, no ICE, no internal combustion engine. But on the Sienna, starting in 21, all Siennas are electrified, they're hybrid. You have a big battery pack. It's a little higher, a little bigger than some of the older Priuses, for example. It is got a little orange plug in the console, the service plug to set the battery, you know, it cuts it in half. The actual fuse that we looked at in that diagram earlier is another location somewhere around this relay center. Here's the relay center. It's a lot cleaned up compared to that picture you saw in some earlier Priuses, but all this is irrelevant. All these things were working, the pre-charge, the SMR 1 and 2 and so forth, and the pre-charge relay and that resistor were all working, obviously because the vehicle said ready, and I had the technician hold their foot on the accelerator to the floor, and that told the Toyota hybrid control ECU, we need power. We need to crank the ICE over. We don't want to just run around for 2 or 3 miles an hour in EV mode. Even if we could, we're going to have full power. That's what the hybrid ECU is doing. It's saying, I need the engine, I need the ICE, and I've got the electrification ready to go. So we're hearing it crank, but it's not running. As an educator, this is something you need to perfect. If you have a hybrid vehicle, you can disconnect the coils on, and it's not a plug-in hybrid, because on a Chevy Volt V-Victor, this won't work. If the vehicle has been charged with the charge plug, the J1772 level 1 or level 2 charge plug, and it's like 100% or 50%, in other words, you've got several miles of EV range only, you can put your foot to the floor all you want to in ready mode, in park or drive or whatever, and that engine is not going to try to start, doesn't need to. But if you're working with this Jeep 4xe behind me, which is a plug-in hybrid electric vehicle, it will try to start, just like this Sienna or an older Prius you may be used to. So that's what we did. Now, this is the part you may not be aware of. This is with Generation 5, I've been told. Generation 4 was just Japan and only. But here in North America, if you have an inverter on your Prius, your Camry, your RAV, your Sienna starting in 2021, all of them are hybrid. That's the top of the inverter. You can see where this is. You know, this is the bulkhead and so forth. Over here is your little cover for the coils and so forth, the beauty engine cover. And I don't know what these modules are. They're irrelevant for our point right today, but look at this. I'm going to zoom in. I want you to see what we have here in the circle. Behind the backside of that inverter is a little silver plate. There are 2 screws to take that plate off. These are just little rivets right here. Underneath them are terminals you got to get to. Terminals you're going to get to, and I've yet to find the perfect probe that will fit these terminals. But at some point in time, I will find that part number of these probes, and we'll probably update this program. But for the meantime, you can use just whatever probe you have. Now you're going to do this with the vehicle, number one, ignition off, like in case study 1, right? Number 2, even that's important, disconnect the 12-volt battery in the proper manner, as we talked about in case study 1. And then number 3, it's going to instruct you with high voltage. You're going to disconnect the high voltage system. I think that was number 3, actually. So yeah, ignition, the battery, 12-volt battery, and then find the service disconnect, which I mentioned was in the console on this particular hybrid. It's the Sienna. And when you remove that, then you're going to, with the high voltage gloves still on, the safety gloves still on, you're going to disconnect, if you're unsure about the power, is it there or not? Did the relays in the relay electrical center, this thing right here, did the relays somehow weld shut? Are they shorted? Are they stuck shut? Because if they are, and you go to take off some battery pack or change out a compressor or an inverter, whatever you're going to do, and the voltage is still there, you kind of want to know. So you pull codes, make sure you're not shorted, have any contact shorted DTCs, and then you're going to pull this with the high voltage gloves on. So you're going to disconnect this connector to get to the second little screw. We can see one screw right here. It's a tamper-proof screw. And the other screw is over here covered by this plug for the inverter. Once you do all that and this cover comes off, you literally, with the high voltage safety gloves on, everything shut off, power down, you know, the orange plug removed, revealing here, you put your probes down in the holes. One is insulated with a red insulator, one insulated with a little test terminal, a black insulator, so you know which is which. And you put your probes with your class category 3 1000 volt meter in the holes and make sure there's no voltage present. That is verifying that the voltage is gone. And this is the first time I've seen this. I've not seen probes. I've seen where you can remove a plate on the Gen 3 Priuses, for example, and other vehicles, but I've never seen points for you deliberately to probe. This is a little higher voltage hybrid, but it's still nickel metal hydride technology. So we did all that, and we actually broke the rules and went ahead and powered it back up. So we then put the orange service plug back in with the gloves on, and we hooked the 12-volt battery cable back up, and then we put the foot on the brake, hit the power button, nothing. Hit the power button, nothing. Oh, we did something wrong. Oh my goodness, we forgot and we didn't plug this back in. So I'm doing this as part of a training program with some other people. And so there's a couple of people working on the vehicle and we forgot to plug the low voltage connector back in. Oh, no harm done. We caught that. We plugged it back in and now we have all these codes. Now the process of all this happening, it took, I don't know, a half hour, 20 minutes. We're doing a live cast of this program at this location on this particular minivan. And that was enough time for the good old 12-volt battery to go low. And nobody really realized it. In fact, somebody put a battery charger on the 12-volt battery. And it was a battery charger that was digital. It was a small charger, and it kept saying 12, meaning it's putting 12 volts into the battery, not the actual status of the battery. And at some point in time, I said, let's check the battery voltage. Oh no, let's go ahead and clear the codes first. You know how it gets when you're working with a team of people. So we pulled codes and we've seen a lot of codes. And the next thing we know is, let's clear the codes then. You know, we'll worry about the 12-volt battery in a minute. It's got to be high enough. We're pulling codes. We're using the factory Toyota Tech Stream to do it. We couldn't clear the codes. It would say failed to clear codes or communication error. And then somebody said, maybe we should go back to that 12-volt battery. It's kind of important. Yeah, kind of. We went back to, we actually measured it. It was 8 volts. 8 or 9, I forget the exact number, but it was too low. The point of the case study is just because you can pull codes, you have enough juice to pull codes, put windows down, the headlights look bright, that don't mean squat, guys. You know this. You need to test the battery. You need to check the battery cables and battery terminals. Just like your father's Oldsmobile, you need to do all those things you used to do, because the 12-volt battery needs to be 12 and up, not 11 and down, because you may have enough voltage to run the scan tool to pull modules for them to wake up and see codes, but some modules will not come awake. And the process of clearing codes takes a little more current, a little bit more juice for that operation than it is just to pull the codes, presumably, because that's when we were having the issue. We simply charged that 12-volt battery on that Sienna hybrid minivan for an hour to get a good charge on it, and we finished it off with a good trickle charge the rest of the evening and cleared all the codes. After we discovered that we had, we had left this little plug off that's required to be removed, at least propped up a bit, to gain access to the screw that it hides. That's the genius of the Toyota engineers. They're thinking about people that make dumb mistakes, even experts, all right? Maybe you're one as well, and you make a dumb mistake occasionally. When this tamper-proof torque screw is removed, you need to do one more. That's got to come off. You can't do a live test. What we're looking for in these holes when this cover's removed is residual voltage of capacitors that didn't discharge, those high voltage capacitors, or contactors that didn't open because they got stuck or welded shut. And so that's the genius of some of this engineering. So it's not always like they're dumber than us. They're a lot more smarter sometimes. We just need to be as smart as them in a practical way to service the vehicle.